Alright guys, welcome back to another episode of WhyPhi. So I thought we'd just start off with rivers because everybody knows what a river is. I'm going to show you the comparison between a river and lightning bolt and how they're basically the same thing. And how, in my opinion, all rivers on Earth were formed by lightning discharges. I'll show you examples of plasma basically behaving exactly like rivers do. I'm probably going to forget a ton because I don't script any of this stuff. I just basically talk off the top of my head. But anyway, let's get into it. So I have a few images here today, just want to quickly talk over, and basically want to show how rivers, I believe, were not formed by water, but by an electric discharge, and then water flowed down them afterwards. And rivers are actually of a fractal nature. I'll get into that in more detail, but just like here, for example, let's just show. Alright, so if you notice, this river has a definite boundary, right? I'm just going to draw it here quickly, show you. So you see this river has this definite boundary. There's some other stuff going on over here, but whatever. So this river has a definite boundary where this smaller river inside here is snaking around, right? You can see all the little places that it has been, but it never goes outside of this boundary. Right, so we're going to see this with practically every river we look at is going to have this characteristic. And this is due to the nature of lightning, because lightning is made up of two vortices, basically. There's a vortice inside of another vortice, and they're spinning around each other, either together or opposite of each other, and the inside filament is snaking all over the place inside the main current. I call it the secondary current and the primary current. And see, this outside big one would be the primary, and then all this stuff inside here would be the secondary. Okay, what's interesting about this is it's fractal in nature, so as you zoom in to this river, you'll notice that there's this primary channel and then a secondary channel within it, and then if you zoomed out, you would notice that this is actually a secondary channel to a much larger primary channel. And that's just the fractal nature of lightning, the way it creates these forms when the electric field is collapsing. This is kind of what happens. Next image. So here you'll notice that there's another one with a primary channel. There's a primary channel, and then all inside of here is a secondary channel that's snaking all over the place inside here. Alright, and this is basically what lightning is doing. Same thing. I'll show you. Like, look at all these lines here. Let's just get rid of this. So, like, check it out. So, like, all these little lines that, you know, according to academia, was formed by this water slowly eating away at the bank and depositing it. And over millennia, I guess, you know, it forms these rivers. You know, the way I see it is actually this is a lightning discharge, and this is secondary channel snaking all over here. And then when the power is shut off, when the electric current, when the electric field has completely collapsed, this is what's left behind. You got to remember the temperatures and pressures involved with all this, right? So when this lightning is actually running across the surface of this Earth, it's liquidating, it's basically liquefying all this stuff underneath it, right? And this secondary channel is doing its thing within there, just carving it up and forming it like clay. It's like, it would be just like forming lava. And then when the electricity is shut off, it super cools because there's, you know, you went from something that's got the room temperature to 30,000 Kelvin, or probably, I don't even know what the end temperature is, it'd be insane. But just insane temperature. You can't even call it temperature at that time. I don't know what you would call it. Thermal decomposition would be off the charts. Next image. All right, here. I know this is a really bad, blurry image, but it's just to demonstrate how rivers form these corners. So whenever they make a turn, all right, what it's doing is it's machined away all this material and it's deposited up here, but it's turned it into stone basically. So, all right. Here's just an interesting image of some rivers up in Canada, and how they, for example, like this discharge path and this discharge path and this path. I call them discharge path because that's what I think they are. The rivers, obviously, they look like lightning discharges to me. But like in my mind, I am just wondering if this path was being machined at one time, and then here's another occurrence of it in the future when it was moving, like across the earth, across the land here. And then this would be its final position after it moved. You know, so this is actually three separate discharges of the same lightning. So I'm not too sure if these are actually individual leaders that were going off all at the same time, or if this is a instance of like this occurred at one time, this occurred at the next time, and this occurred at the next time as this was moving. You see what I'm saying? So it's really hard to tell what was going on here geologically, quote unquote, because these lightning was actually moving across the earth, like it was moving, making these forms. I find this really interesting because this river here system connected here, and it also went this way and connected here. Meanwhile, and continued upwards. Meanwhile, this river came across this way and continues this way. So there's like this weird square shaped forming sharing of rivers and intersecting here. It's really crazy. I thought that was neat. All right, next firm. So here's the kind of fractorial thing I wanted to talk about. And in this instance here, we have actual water pushing its way through silty material. So this is what water does naturally, is it kind of like snakes its way through a silty material. What we're seeing is examples of Lichtenberg discharges and not water pushing its way through a silty material, which is what we see here. But anyway, I just want you to show you that there's this fractal going on. So we have the width of this main channel, and then we have this width of these secondary channels within there, right? And this is a close-up view. And then as we get further away, you'll notice that we have, again, the primary channel having a certain width, and then the secondary channel. This is actually the lightning example of the lightning discharge going on. This is what has carved into the rock, and then here, this white silty stuff left behind is material that rivers have been depositing as it's washed away after. Okay, because there was a water event that occurred where it covered all of this with water, and water had washed all away, depositing things, depositing material on top of the land. Because what you're seeing here, this discharge I'm showing you, is actually the bottom of the earth, like the bedrock. And then on top of it has been a deposited layer of material. Alright, so you can see this fractal nature going on. So we got a width, and then this secondary channel has its width. And as you notice here, these Lichtenberg fractals everywhere. This whole land was basically machined out. So this surface here was the top of the surface of the material that was there, and then all of this was being machined out by, or electrically removed by the positive discharge that was going on. And all this material basically got gasified and liquefied, and then it was pulled down these channels and deposited all over the place inside the river channel here. You notice here again we have the primary current and then the secondary current that's snaking all over inside here. Right, and I found that in places where the earth was more resistant, I guess you could say, this snaky thing was more pronounced, like it was tighter coils. And then when the earth was less resistant, these coils would be more elongated, so it'd be straighter. And also, the closer you got to the source of these discharges, the more chaotic the river becomes, like oxbows all over the place. Everything just becomes a chaotic mess. So, and then the further away you got from the source, the more, the less chaotic it became. So here's just another example of the primary with the secondary current inside of it. So like this is the actual current that was flowing inside the primary channel. So this was an electric discharge going on, and then this was a secondary one snaking around all over inside here. But it'll never leave the bounds of the primary. Look at these beautiful example of Lichtenberg discharges. What another thing I find is that if this was formed by water, it has an uncanny ability to find a 90-degree angle to join a river. So every secondary feeder river, they call these, every secondary feeder joins exactly at 90 degrees in most cases. I'm saying in most cases because there is an odd time where it'll come in at an angle, but it's, just because of the way and nature of the lightning moves and stuff. In all instances, it comes in at 90 degrees. Just look at this. One giant arc, and then inside of it you have this secondary arc snaking all over the place. This I found interesting, how this river managed to completely carve its way through a mountain range. I mean, if this was in fact water doing this, how it managed to completely carve its way through solid mountains in order to make its trail. And look at how it smoothly pushed up this, and where it machined this down as this arc was snaking its way across the earth. 100% lightning bolt. So these Oxbow Lakes, I've been thinking about them for a long time, and after seeing how water moves naturally through a silty or muddy substance, I find that it's almost impossible for it to naturally make this type of lake, because it just doesn't work. It doesn't work that way in natural water flowing through substance. This is a clear example of a lightning arc that had snaked its way through here, and you can see where it left its trails as it was like bending outward and away, and then as it moved back this way, it just left this behind. It left this deep impression in the earth. Here's another example. I just want to show a topographical map showing this area where again we have this nice primary discharge and then this secondary current. Alright, here again I just wanted to show you all these little tiny arcs that were made by lightning as it moved through here, as it expanded its way through here. This wasn't formed by water, in my opinion. This wasn't formed by water slowly eroding away at the banks and depositing it. And then what, like, how did it stop? Why did it stop? And then make this channel instead? Like, it just doesn't make sense to me, anyway. This is the Mississippi River, and they've kind of mapped out all the different, according to them, all the different times that this particular river had been in this area, and we've got this nice map showing that, but to me this is all just one electric arc snaking its way around. I can even show you examples of how these are all part of it. It's all formed at the exact same time. This wasn't water carving a separate path or anything. I mean, look at how many arcs there are in here. You'd think that water carved all these, it would take millennia. I mean, like, it just didn't happen that way. This was all lightning discharge. Completely, 100% lightning discharge. Alright, see, look at this. See how this river here has a primary channel and all the secondary channel is snaking around all over the place here? It's incredible how many little snaky little areas it's been in. Look at this. Great example right here. All these little arcs. You know, so this was actually this secondary current was like carving its way through here, snaking way around. Right? Look at this. Huge arc here. Huge arc snaking its way around. This is like, you'd think this tiny little river made all this? No. Impossible. Or it's going to go down into the desert a bit. If you notice here on the ground, all these little wall-like projections, because this is all built-up material. This is all like Lichtenberg figures. Like when lightning hits the sand and it amalgamates it into glass. This is what it left behind as it was snaking all over the earth. It left behind all these figures. See this? And look at this, how far it goes into the desert. All these little walls and little things you see sticking out of the ground were all left behind by little bits of lightning. And if you look here, you follow this little trail that used to be a discharge going on, right? And it brings you into this mess. Look at all these little tiny discharges going on through here. This is amalgamates, this stuff that's left behind. And all this stuff here, all of this is lightning that was snaking through here and carving it up, machining it out, leaving all this behind. Look at how much of it there is. It's huge. Right, so here's what I'm talking about with these Lichtenberg figures that are like feeders, secondary feeders that are coming off the main rivers, that they call them. Right, this is completely the way lightning behaves. This is how electricity behaves. You know, it comes off at 90 degrees to the main channel all the time, right? So you got this main channel here. You got a feeder that's coming off this 90 degrees. And then within that, you've got these other feeders coming off at a 90 degrees. And it's all just electrical. 100% electrical. Like, you wonder why this land isn't being farmed, because it can't. It's completely turned to stone. The soil is different there. It's not farmable. Like, here's a great example of the primary channel with the secondary channel. You know, this is all Lichtenberg figures. This is all lightning arcing its way through the earth. And then water has basically come here afterwards and is flowing down it naturally. If you follow this back to the end where the water's flowing to, you'll actually get to the source of the lightning discharge, because the water's flowing downhill towards that point. Just look at this stuff. Just look at this stuff with fresh eyes, imagining it as lightning bolts, carving all this, moving across the earth. And we've already talked about how hot that is. Just a everyday standard tiny little lightning bolt is 30,000 Kelvin in temperature, which is hot enough to boil carbon. You know, pure carbon can boil it 8 times over. No sweat, like instantly. We're talking instant temperature. What a mess it made here. Look at this stuff going on in Australia. This is crazy. See, that's not rivers. That's land looking like this. Trees. Wow. Amazing. All 100% lightning. Massive scale lightning. We're talking the entire Earth, possibly the entire electric field of the Earth collapsing. Lightning would have been arcing across the Earth for several seconds or longer. You know, when the electric field was neutralizing, it would be echoing back and forth between the negative and positive continuously for a while. I couldn't even say how long it was going on for. But here's an example of water flowing naturally through a silty substance. Alright, so this is kind of like the primary channel, and we've got this secondary channel's buried underneath the silt here, so we don't actually see the actual primary channel, but what water's doing is flowing through this mud, And it's making these little islands and snaking its way through as it's, you know, hitting the resistance of this material, and it kind of curves and makes its way. But that's not what we see with river formations. You know, there's nowhere here do you see feeder channels coming in at 90 degrees. No, they just form little islets, the islands that look like eyes. Here again, so I mean, like, just a couple examples of this is coming off of a glacier somewhere or whatever, flowing through the mud, you know, and nowhere does it look like Lichtenberg figures with electricity, how electricity comes in at 90 degrees, and the way that the lightning is sucking in all the material. It's just, and the points that it naturally forms these branches, it's 100% lightning. This is kind of a bad example because this is basically canyons, but what I want to talk about is how rivers profiles look. Whenever I'm approaching a river, you always have to come uphill, and then when you get to the top of a hill, you got to come down the hill to the base of the river, and then you've got the riverbed which flows through this channel, and then you got to go back up a hill and then down a hill again on the top. So it's got like this. That's a bad example. Right here is a good example. So you come up the hill and then you got to go down into the valley, and then you go up the hill and back down again. And so this profile is exactly how craters look. You know how impact craters, quote unquote, how they look, right? Well, this riverbed formed exactly the same on its profile. It's just that it's not in a circle, it's in a straight line, and it's doing the exact same thing, basically, the way it machined away this earth. I want to show like how this groundwater aquifers are always coming from the bottom of a river and stretching outward into the rock, almost in these fractures, right? Because this is obviously formed by lightning and not by water. Okay, I just wanted to mention Victor Schwalberger, if I pronounce his name right, hopefully. He did a lot of work in natural energy and implosion energy and that kind of stuff, but the natural energy, he called it implosion energy, which is basically the negative discharge, in my opinion. And that's why it's kind of like been, you know, not really talked about much, because I'm not too sure if they're aware of negative electric discharge or not, they being scientists, academia, I don't know. Anyway, so let's see. So basically what he was talking about is how water flows, how the motion of the water is flowing, right? This is just his diagram of water flowing in a river, his explanation. And then how it like erodes down, and the motion of this water kind of gives the idea of the erosion and the deposition, right? And then here at this point of neutralization, it kind of like releases that energy in order for it to start rotating in the anti-clockwise direction. Because it's rotating in one direction here, and then it has to stop and rotate in the opposite direction, just like your blood flow in the heart. So he's comparing it to this natural flow of energy, all right? And basically what I'm saying is that electricity flows in a similar fashion. So you have this whole river is flowing, but then inside of it you have these currents that are doing their own thing. And so it's basically how lightning works too. Just another example of his work, how he's showing the flow of the water through this channel. Again, just another example of water flowing, but it's also a great representation of what the electric current is doing, right? So you have this like really high, fast current flowing down the center, and around it, which we call the magnetic field, is flowing at a much slower pace. So it doesn't have as high of energy as the electric current going down the middle than it does around the outside, but it's still the same thing. You know what I'm saying? And so this is kind of what lightning is doing. You've got this really high spinning current down the center, filament, and then around it, it has its slower filament spinning around it, all right? That's kind of how the energy is moving, and then what we see as a lightning bolt are the gases being ignited, but this is how the energy is flowing when that event is occurring. All these systems formed by electric discharge. These are all Lichtenberg figures. There's not water naturally forming. This water doesn't naturally do this, in my opinion. This is 100% done by electric current. Electric current, particularly here. See, here's another example of his work with Australia. Australia's got some special stuff about it. I'll talk about it in a later video, but what I find interesting about this is that look at all these different systems going on here, like an incredible amount of them. Tiny individual systems of rivers, and then this going on. Like, what happened here? Curious. Australia's rivers are crazy, and just tracing them is crazy, but if you just look at this is just a sound. I just want to show you how closely these represent Lichtenberg figures, and in my opinion, they are. They're basically all lightning discharge. I'm gonna get into more about Australia in later episodes about the rainbow serpent and the Aboriginal stories and stuff, and how they believe that they were witnessing a creation when they watched this event occurring. So here's just an example of what I see going on. I mean, there is way more. This is just a couple examples. I have 2 examples, but I just want to show you how the lightning bolt or the arc was moving across the land at this time and how it actually formed this peninsula. This is Florida here. Huge Florida landmass. This is the southeastern part of the southeastern part of the United States. And you know, this arc had slowly moved its way down and made this huge landmass and left all this stuff behind. Like it's clear, you can see it. Right here is just another example. I'm not too sure which direction this was going, if it started here and made its way that way, or started here and made its way this way before the power eventually quit. But as you can see, this is basically what I imagine in my head going on. This lightning bolt was amalgamating all this material and building up all the land as it moved. You can see a Lichtenberg figure here blast out into the ocean. Was it a continuation of the Amazon River here? Who knows? It's possible. How did water form that if that's the case? See what I'm saying? This is my Exhibit A for plasma discharge creating rivers. If you notice, this is a actually, I don't know what kind of gas this is, if this is nitrogen or krypton gas, but either way, this is a plasma ball, and I'm showing you electric discharge within that plasma ball, how it's snaking around here all crazily, and then it's got these little connecting arcs just like rivers do. Here's another example of a plasma ball showing its discharge and how similar they are to rivers, right? And this thing is snaking all over the place, forming all this stuff. And so as long as this power is turned on, if there was actually material here, it would be rearranging it continuously. Again, this thing is snaking all around. You can actually find this particular image on as a YouTube video. You can watch this thing and you can see for yourself. Here again, another example of a plasma ball with all the discharge and arcing going on. Looks just like a river. Lichtenberg figures. This is another great example. It's like it actually shows, like, you know, the snaking of a river, and then inside here we've got this straight path, genuinely straight path. But the primary path is following, secondary path is following. So basically what I'm saying is that all the rivers on Earth, actually most of the entire geology on Earth was created by electric arcs moving across the surface of the Earth and actually building it up. It was taking it down in one place and building it up in another. So like for example the desert areas, you know, they turned the desert areas into sand and then built up the mountains in other places. It all happened when the entire electric field of the Earth collapsed. And it possibly collapsed twice. Not just once, or more times, but from what I can tell, like there was one initial discharge that actually created the Earth and formed an old Earth that we know on these old maps, which we're going to get into in later episodes. And then it happened again and altered the Earth that we see and left us with what we have today. So that's basically all I have for you today. Probably next episode we're going to cover mountains. I'm going to go into more detail about the whole discharge on the Earth. So leave a like, share, subscribe, and all that jazz. Put a comment down in the comment section below about what you think. And we'll be definitely getting into more detail in later videos. I just kind of want to keep them shorter for now so they're not so long. And yeah, so look forward to the next one. Bye-bye.